If something disagrees with your experiment, then typically, but not always mind you, it means the idea being tested is false. But we can never rule out the fact that there are rare cases where it can also mean there is a flaw with the experiment, as I said earlier. But this split in frequency, more often a theory is wrong when the experimental results disagree with it than the experimental results are wrong in some way and the theory is right, can tell you nothing whatever about which situation you are in when you encounter this problem. Anyways, as we said, experiments are not the whole story. We must ask, what is the accompanying explanation? If there is none, we have explanationless science. In other words, we have the facade of science, the thin veneer, an imposter, the shape of science only. Science is ultimately about explanations of the physical world, not experiments. Both, however, are necessary. But what about in mathematics? Well, there, experiments are typically not needed, although there are kind of exceptions to this, especially in applied mathematics, or something like the four-colour theorem, which says you only need 4 colours on a map to colour it, so that no 2 adjacent regions have the same colour, which is kind of surprising if you've never thought about it before. Anyways, in a sense, this did require a sort of experiment. It was proved using a computer to check the possibilities in abstract space that were just too numerous for a human to do. Whatever the case, in mathematics we less often speak of experiments as we do of proofs, which then serve as refutations or criticisms. A proof of a theorem is a criticism of its negation, or in mathematics we might perform on a completely abstract inequality of some kind, a substitution where the result disagrees with a prediction of the theorem, a special case of reductio ad absurdum. Or if we know some result holds, like say Pythagoras' theorem, and we actually substitute in numbers and it turns out the equality does not hold, we've found an error. Identifying an error is a kind of criticism, and that allows progress too, identifying and correcting errors in this way. If we have a general case we know is our best explanation, like the Pythagoras example, and a purported special case fails, we have a problem. Maybe we've disproved Pythagoras' theorem. More likely we've made an error in our substitution and subsequent calculations, or both. Basically, criticisms in mathematics amount to computations, i.e. workings and calculations, that show some theorem or some guess is wrong. I'll say that again. It is about showing something is wrong. And that is the role of criticism. I feel like I've got to labour the point. Criticism is about showing that and how something is wrong. And the criticism itself is accompanied by some explanation as well, a reason why that something is wrong.